Hi everyone, welcome to today's session. As you start creating your models, there would be stages where you might hit a roadblock. You might be in a need to model a process that is new to your domain, or you would need a component that does not exist in the library that you are using. How do you approach in such cases? Probably a good starting point would be to investigate other domains and see if something can be learned and reused. In this session, we will use the principles, learn from other domains, and check some examples. The principle of learning from other domains is widely used in our day-to-day life. You might have used Velcros at some point. For example, you could have used it to fasten your shoes, or organize your tools, or put a cover over your furniture. But do you know how this concept was invented? It was in 1940s when a Swiss engineer named George de Mestral was hunting in the mountains. During the hunt, he realized the tiny hooks of the cockleburs were stuck on his pants and his dog's fur. He observed this under a microscope and found how the hooks were engaged in the fabric of his pants, and subsequently invented the Velcro. You might be astonished, but they have even found their usage in space due to being very light in weight. It was used in the astronaut spacesuits to secure pockets and other items. Even they were used on the astronauts' watches. This example shows how a phenomena from nature has been used in a new application. Can you think of some other examples where we have borrowed ideas from other fields? Let's check some examples from industry. The concept of agile methodology was developed in the software industry. However, now it has found its usage in several other domains like marketing and design. The scratch-free lenses that has made our vision much cleaner makes use of an invention from the space industry. And finally, the bullet train's unique design has been inspired from the beak of a kingfisher. But how is this relevant to modeling? Can we use learnings from one domain in another domain? Are there similarities? Yes, when it comes to modeling, in most cases there are some similarities among the different fields. Let's consider three different domains of electrical, fluid, and mechanical. Even if these fields are very different, they have some commonalities. All these fields have an energy source like battery, tank, or flywheel. They use a transmission system for transport of energy like wires, pipes, and shafts, and also have some control elements to control the flow like resistors, valves, and brakes. Due to this commonality, sometimes it is useful to see how a problem is solved in one domain and check if those solutions can be reused in your domain. In this session, we will explore the concept of sales funnel used to model strategies for online marketing. But first, what is a sales funnel? A sales funnel helps marketers understand a customer's purchasing journey, while also identifying what stage of this journey the customer is at. These insights can be used to decide which marketing channels and activities will best guide the customer towards a purchase. A sales funnel also allows marketers to tailor and optimize their activities and messaging to increase conversions. How can we model such a system? Perhaps we can borrow the concept that we used in the spread of an infection model and model such a system. In this model, you can see the different stages a customer goes through from being unaware of a product to finally becoming a regular customer. In this simple scenario, a completely unaware customer watches your ad and becomes aware of your product. As the customer sees more use cases and examples, it creates a desire and it takes a trial of the product. If he sees usefulness in the product, then he becomes a regular customer. Let's get started by reusing the components from yesterday's session. So Leo, today we are going to explore this concept of sales funnel example. And as I explained in the explained now, is basically, let's say you have a software product that you have developed, and once you have the developed the product, how would you like to like how is the journey a customer goes through, uh, like from being completely unaware to being an aware customer, right? So the concept is, you are completely unaware of a product, you look at some ads like Facebook ads or YouTube ads, you become aware about it, and once you're aware, if you look at examples, use cases which perhaps resonate with what you are doing, then you go for a trial of a trial of the product. And and once you're using the trial of the product, if your experience is good, then you become a customer, right?
Right.
So this and but this process of transitioning between different stages looks very similar to what we discussed yesterday.
Yes, just like the epidemiology model.
Yes. So why not, let's get started and try to create that model, uh, and then see how the model behaves, right? Okay. So let's get started. One thing before we get started, Leo, there was a confusion. There was a question in the community which created some confusion. So what happened was, during yesterday's session, some of our participants, they started creating their model, and then when they opened System Modeler, they had the default Model 1 model open, right? So which is the base model that is, or which is the base model that is open when you run System Modeler. And then what happened was, they started playing around uh, with the different components, and they saved it in Model 1, and then they tried to rename it to Modelica principles dot start simple, um, dot exercise dot thing, and they had some issues. So perhaps we should clear that today before we get started with the exercises.
Yes, yes. Also to
Right.
see what I mean to
Yes.
that way you can show exactly where to look
Yes. So the
when
thing
creating
was,
a model.
yes, yesterday we wanted to start with, okay, let's take today's example. Let me get started again. So we got a question that uh, there was a problem when people opened System Modeler. They were in the model 1, so which is the base model when you open System Modeler, and they started modeling using this interface. Whereas when we were demoing the example yesterday, we were using the step 1 class, right? And then what they wanted was, they wanted to rename the model 1 to modeling principles dot other domains dot exercises, and they were not able to do it. So the two questions, like, uh, first of all, uh, let's clarify a bit. When we use the name like modeling principles dot other domains dot exercises dot step 1, it might be trivial for some part of the audience, but for some it might be new. So what does this naming scheme tells us, Leo?
Ankit, Ankit, can you pause a little bit because someone put a comment that they cannot hear you. So can someone else confirm if there is sound or not? Hopefully, someone in the chat.
Right.
Yeah,
I can hear you perfectly.
yeah.
Okay, Robs, can you hear me?
Yes, and I think Luke also can hear you. I guess this is just the user situation.
Okay, okay,
Okay.
no problem. It's fine. It's better to cross check than just go on. Anyways, so Leo, if we can just take a minute and describe for people who are not new to the object oriented way of doing things, and then what is the difference between just a name like Model 1, and when we have a name like modeling principles dot other domains. What does it mean?
Yeah, I think that the best way of understanding it is by looking at the hierarchy of classes. So it is like the files in your file manager, depending on the operating system. You have folders inside folders, and in a in a in an operating system, it is usually with a slash, the separator, but in System Modeler, they are separated by a dot.
Right. So what this means is I have the modeling principles library, and inside that I have the other domains, and then I have the exercise, and I have a step one. So I have actually not given a name, specific name to step one. It actually derives the location, and then it gives me a expanded path, right? but
Right.
but what if, Leo, someone actually took their time and they created a model in model 1? Like, for instance, let me just drag a component here, and that is in model 1, and I want to move it into my exercise folder. Let me
So,
just zoom out of it. How can I move my model 1 into my exercise folder?
so I guess that it will be just like as in the file manager of Windows, like
Yes.
dragging it.
So you can just drag it and put over the exercise package here, and then either you can rename it. For example, I can give it a name, step 6 or step 5 for this package, and click OK. And then you could see that the model 1 was copied here. And if I double click, and you can see I gave it a name step 1, but now it shows me the expanded path of that file. So it's modeling principles or other domains or exercises dot step 1, right? Okay, so with that being answered, let's get started with today's um, example. Okay, so for today, I will use the other domains step 1 uh, uh, model to create our model today, and let me show what we are going to create. So Leo, you can see my screen, right? Okay, so we will use the population component that we used yesterday, and then we will use the proportional transition uh, component, and we will just use only those two components, and then we will try to recreate this model, right? So let's get ahead and let's start creating our model. So for this session, we have like you can find the population group and the transition elements inside the components package. And let's get ahead and start dropping the population group here, and then the quantity dependent transition, right? Uh, and I will start by renaming my population group. Okay, let me zoom in a bit, and let me rename it to unaware, right? And once I have the unaware thing, I will create my transition and name it as ads. Right. Uh, right. So I have two of my components done. Now, if I want to create the other components, either I can drag and drop all the elements here, or I can just select all the components, right click, and then select duplicate. Or you can also see the keyword control plus D or command plus D for Mac users. And if I duplicate it, you can see that this is duplicated. So from henceforth, I will use control plus D because I'm using Windows, and then I will duplicate my components. Right. So let me go back. So once we have unaware ads, from the unaware stage, we want people to move to the aware stage. So make it aware, and then uh, I'll move to trials. No, this is examples maybe. Yes. And after looking at examples, we will have trial users. So I will name it trial, and then I will duplicate my trial group by pressing Control D. So I have a new component in, and I will move it here, and I will press F2 to rename. So select the component and press F2, and then I will make it rename, give it a name, customer, right? And the process of from trial to customer, it's mainly the experience, right? So now, using the components that we discussed yesterday from the SIR model, we have reused the concept for the sales funnel. We have all the components now. The next stage is to connect all the components. Either I can press the connection line tool or press C. I will press C in my keyboard, and then I will connect all my components. Right. Okay. Okay, Leo. So I will give a few 1 or 2 minutes for people to do this. Um, do you want to add anything to what we have seen so far, Leo, or would you like to comment on something that people should be aware of when they do their models?
No, I don't know. I mean, for me, it seems clear so far.
Yes. Yes. Also, one short thing that I sometimes also do. I kind of like, sometimes I want to add more description to my model. So I also sometimes use the text tool. So you can see the A symbol here, the text tool symbol, and then I give some comment like model of the sales funnel, something like this. So this is also a good practice. Like when you create models and when you are kind of done with the model, start writing some text. And also sometimes I create shapes. I will not do it now, but you can also have shapes and you can distinguish, let's say, a particular section, and then I can give it a color, something like this. No, something like this. This was the color didn't was is too bright, but like you can give more um, life to your white models. Do you also do something like this, Leo, when you create your models, or you're such an expert that you don't even need all those things?
No, I actually do the boxes to separate the different subsystems.
Okay, so because
Uh,
you deal with electrical systems, maybe you want to define the sources and then like some auxiliary functions or something like that, right?
yeah, like different sections of the circuit. I try to put them together, and I usually use like dotted lines
Hmm.
and labels.
Right.
But
Okay,
it's
Leo.
nice. It's nice that you can add like a happy face to your customers.
Yeah, yeah. Um, uh, Also, in some cases, Leo, I also add image. Like for instance, in some cases, I would like to have a background image, right, rather than showing a canvas. So if I use a bitmap tool and if I have a image file, I can use it and then put it as a background when I am presenting my model. So that is also sometimes for some of the projects I do. Okay, Leo. So I think people would have done this the steps so far. So now let's go ahead and initialize our components. So let's say we have unaware people from 100. Let's give a value to the ads transition factor as, let's say, uh, 1 per day. Aware, let's keep it at 1. Examples 0.0.5, because I want the other stages to be more difficult than the first. So when I have the first as 1, I don't want this stages to be much faster. I want them to be slower than the first stage. And then I will have zero point 0.1 per day for the last. And then for trial, okay, there is another trick, Leo, isn't it? Like rather than if let's say if I want to give the same parameter value, the same population data to 3 components: aware, trial, and customer, right? It's cumbersome to select each of them and then write one for all of them, right? Is there a better way of defining them once?
I guess that is if the components have like common parameter names,
Hmm.
they will be it will possible
Yes.
to change them all at the same time, right?
Yes. So let's press shift and then aware and trial. So when I press shift and I select aware, trial, and customer, you can see that it tells me that the initial population is common among all the three components, and but it has no common value. And here I can give a value of 1. So now if I press customer, you could see it has 1, customer, trial 1, and all, right? So you can, if you want all your components to get one value and you want to quickly initialize them, you can select them using shift and then you can give them the same value. Okay, so we have a transition of 1 per day for ads, zero point 0.5 for examples, and zero point 0.1 for experience. The final step is to set the experiment setup. So I will select the experiment setup here, and we are using the default days for time unit and stop unit 30, right? Let's go ahead and simulate this. Right. Okay. So now let's plot the aware this population first. Okay. Um, right. But I don't have the theme. One thing, Leo, I actually one feature that I actually like, which I disabled before the start of the study group, is to have a global setting for my themes, because all the time I have to go here and select a theme. Um, uh, it's too much work for me. So I usually have a global plot theme, the plot theme set globally. And let me just show how to set the plot theme globally so I don't have to do this again and again. So you can go to tools, uh, options, and then under plot. So tools, options, and under plot, you can select the theme, and then I will select this theme here, and you can select between different other themes, and then click OK. Right. So next time, let's say if I create a new plot and then I plot something here. Uh, okay. Uh, right. Okay. Sorry. For some reason, I selected the parametric plot. Okay. Anyways, uh, uh, so here, if I select a new YT plot and select my display population, so you see now it retains my plot theme, and it is very, and I personally find it useful, and I use this plot theme because it helps me easily visualize if there is any zero crossing, or when two plots are merging, it helps me visualizing it better. So personally I like this plot theme. Okay, so now let's go ahead and check the results for um, okay, we wanted to have unaware, aware, then we had the trial, and then we had the customer, right? This is such an interesting case, right, Leo? All the unaware customer were so impressed by our sales funnel that we had no leakages to any competitor, and everyone bought our product. It would be nice to have such a product, right?
Yeah, maybe you're selling ice cream. Maybe everybody likes it.
Yeah, maybe. But here, yes, of course. And the thing is, you can also imagine adding different other stages. For this scenario, we have this very simple sales funnel, but as you try to add more complexity to your model, you can add leakages at each and every stage. And then once you measure data from, let's say, your Google ads, then you can compare, and then you can see at different stages how many people are getting converted, um, right? But for today, we just saw what we call a sales funnel, and we saw the different transition stages, right? Uh, okay, um, and let me just save my plot. So add plot to model, and then I will go default plot, and I will name it results, and I click OK. Okay, then, right. Do you want to say anything up to this point, Leo, or any comments, or do you want to say anything, or is it fine so far?
So everything's fine so far for me.
Um, okay. Okay. So let's take 2 minutes so people can actually plot these things and then save their plot. And in the meanwhile, if there are any questions,
Okay, so there is one is uh, from Helmut says that if there is a label functionality to display parameter values next to the icons, I think it is possible, right? When you create the model, you are able of displaying the value. For example, if you drag a resistor,
mhm,
it has the value.
right. Uh, yeah, is there a label functionality to display parameter next? Oh, Leo, let's not get ahead of
Okay, okay.
ourselves. This feature is there in the business simulation thing, but okay, but since you are a very good friend of mine and you have requested this, uh, let's go ahead and implement it for our icon. Please note that this is an advanced feature, and I'm just trying to show how it's done. I'm not expecting you to everyone to do it, but um, let's say you want to display the parameter value here, Leo, right? And we can only display the parameter value, right? Just to be clear, we are not going to display. We are not going to have a dynamic diagram here.
Yes, we cannot
Right?
display simulation values.
Yes. So let's say we want to display. So what I've done here, I've selected my component, and here you can see we have icon view, diagram view, and text view. Now I am in the icon view, right? And I want to display a value here on the top. I think if I remember correctly, I will just no, I'll create a text tool here, and then I will put it the text tool, and I think I do percentage and curly braces, and then I say just correct me, Leo, if some of the syntax is not right. I don't remember it
Okay, I mean,
properly.
we can try it.
Yeah, we
Try
can
the
try it,
initial
of course.
population.
Population, percentage, curly braces, and the name of the parameter, and click apply. Oh, works. So now we have 100 people, one people, one people, one people. The unit is people, so it, it feels a
Right.
bit.
It's nice that it even shows the units.
Yeah. Yeah. Yes. Now I think I should have chosen a shorter unit, but it's okay. Uh,
There is another question that I'm not sure if I understand correctly. Uh, Transition component cannot work as connector also. Uh, so the transitions, transition lines are, even if they're connected to two sections, I mean to two components of the model, they are not like simple lines, right?
yes.
Simple connections. They have
Yes.
some logic
So if
behind it.
this is also an advanced feature, but for people if who are eager to know, if you double click on the component, you will get into the class diagram, and then if I see into the equation, so so there are equations involved. It's just not uh, it's just not um, 2 points, right? We have equations that define those things, um, right? Because yeah, so it's a bit more it has a bit more knowledge. Okay, Leo, so let's get back to where we left. So
Okay,
so far,
now that
yes.
you're there, there is another question. So, for
Mhm.
example, if you change a parameter in simulation center,
in Simulation Center.
So
You,
yeah, go back to Simulation Center and, for example, change the initial
how can
people
we?
and how to save it back to the model.
Right. That's a very good question. Okay, yeah, this is also very this is common. It's a very good question. So what happens is when you start working on your model, you start playing around with the parameters, and let's say I go to the parameters tab and I have ads, right? And I have ads as one per day. Now let me change it to zero point 0.8 per day. And then I simulate this again. I have a new behavior. And perhaps this behavior is what I want, and I want to store this parameter value in my model. So either I take a note of it, go back to Model Center, and then add it there. It's easy when I say about one parameter, but in some cases you are varying 10 different parameters, and in that case it becomes very difficult. So how to update your model parameters from from the simulation center? To do that, once you have done those changes, you go to File, and then you go to Save Experiment Settings. So you go to File and then Save Experiment Settings. And here, uh, please note that these values are in per second. So the thing is, under the hood, or system modeler works on the base units, the basic SI units. And when we have specified the value in zero point 0.8 per day, it has converted it to the SI, to per second. That's why you're getting the small numbers. So this is the new value, and this is the old value for ads dot factor. And here, if you do multiple changes, all the changes will be listed here, and you can check or uncheck what you want to carry forward or save in the model. So for now, let me go ahead and click OK. So here my value was zero point 0.8 per day, and I saved my experiment settings. I go back to Model Center, and then if I click Ads, you see that my value is now zero point 0.8, right? So it is very common that when you are working with your results, you change the parameter values, you change the initial values of different things, and once you do all those changes, you can go to File, Save Experiment Settings, select what you want to carry forward, and then click OK.
That
Okay, Leo.
also changed the simulation time, right? If you
Oh
simulate
yeah,
more or less
yeah,
time,
yeah.
etc., it will
Yeah,
it will
that is
save
also
those
that is
values.
also true, because when you have the first simulation, you don't know what is the interval, right? What is the day interval? And let's say you want to have it for 10 days, and then rather than going back and saving the experiment setup, I change my stop time here, File, Save Experiment Setup, and then here you see, since it is a setting, you see in the changed label you have the stop time marked in blue. That means that something has changed in the stop time, and do you want to accept it? And if I click OK and I go back to Model Center, you might observe that to go back to Model Center, I am pressing this Model Center icon on the top right. So if I click here, I go back to Model Center, and let me click the arrow here, go to Experiment Setup, and you can see my stop time now has changed to 10, right? So all the parameter initial values and experiment setup can be carried forward to your model. Okay, Leo. I so I think people would have been able to do um, to do this so far. Um, Now we have played a lot with our simple uh, model for the population group that I created for this study group. But let's go ahead and use a library that is built for this system dynamics modeling. And that library is, let me go back to my presentation first. And that library is the business simulation library. So people who have not, who joined late, you can find the business simulation .sma file in the uh, download material section. So take a few seconds, or take a minute, and install it in System Modeler. And let me go ahead and install it in System Modeler to show how it needs to be done. So now I don't have the business simulation library um loaded or installed even. So once you download the business simulation.sma uh, from the download section, you can just drag and drop, as you can see here, you can just drag and drop the SMA to System Modeler, or you can just double click on the SMA file as well, and then it will give you this window, and you have an option here: load now and configure to load at startup. And if you select this, every time you run System Modeler, this library will be auto loaded, and you will find it under the library section. There are some cases where you don't want to load it all the time, and then you can just simply uncheck this. But for now, let's keep it checked. And then I will click install libraries. And here you can read the library license. I have read it partially before, and now I would accept the agreements and then click OK. Yes, right. And then here you get the messages saying that it has been successfully loaded. Right. So so I hope everyone is able to uh, install the business simulation library. Um, uh, but this is but let's say if you want to try, just I want to cover this here. Not only business simulation libraries, we have a lot of other free libraries. So all the libraries are free. You can go to System Modeler libraries page. Let me put it under chat so people can follow. Right. So you can go to the System Modeler libraries page, and you can look at all the free libraries that are available, and you can directly install it and use it in System Modeler. There might be some libraries relevant to your domain, or we have some libraries that helps you communicate with external systems, external applications like the OPC and OPCA classic library. You can make use of that. Leo, there was a question like, can are people only limited to the libraries that we showed in this library page, or can they find other libraries as well? How does this work?
Yeah, so under the hood, there is a modeling language called Modelica, which is the code that you show when displaying the connector. And there are other libraries made with that language. But the main difficulty that you may find if you download a library from the internet is that sometimes they are made with a different tool, and they are not as strict as ours when checking compatibility. So it can be the case that you download, and we report like some warnings or errors that tells you like this is incorrect or this is incorrect Modelica. But if the libraries are compatible, then it's possible just to load them and use them. And in most of the cases, what I end up doing is creating my own libraries based on either on code or based on the available components.
Uh, there was one question I saw, Leo. Um the file formats that we have, like we shared files called Modelica principles.mo that people have been using so far, and now people saw our participants saw this file with an extension .sma, right? So we have a .mo file and .sma file. What's the difference?
Yes, the MO is the Modelica code, so it can be if you open with a text editor the file, you will see the whole code of the library or the model, and it's plain text. But sometimes libraries are comprised of many files, and in that case, it's more practical to archive them, and that's why we have the system modeler archive that is the .sma.
Yes, so the thing is, sometimes you have images, sometimes you have CAD objects, sometimes you have a Mathematica notebook, or sometimes you have other resources that you want to share along with your model file. So it's basically a packaged structure, right, which has content just more than the text file. So you can have your assets, and you can have your nice icons and all those things, right? Okay. Right. So let's introduce our next step. Right. Okay, Leo. So now, so far we created our model using the simple components that I developed. Now let's get started with this library and try to recreate what we did um, using the business simulation library, so that we can match and then also understand how the business simulation library works, right? Okay. uh, so let's get started with that. And I will open a new blank screen here where we can start modeling. Before we do that, whenever we start exploring a new library, we want to first look into the different examples that are there, so that we can understand like how the different components work and how we can start using it. I have opened the SIR uh, model from the business simulation library. It is present under the examples folder, SIR, just because we have covered it 2 days back. And then by looking um at this model, we can try to understand which type of component matches to what we did. Here, if you see, we have the susceptible group with this red um, uh, like boundaries. And then this blocks looks something similar to the population group, right? And in this and the business simulation library uses a system dynamics metaphor, which was developed by Jay Forrester. And then this population group, or these groups, or these containers, they are called stocks in the system dynamics lingo. And then they have we saw different types of transitions, like proportionality transition or a constant transition, and those are called flows. So we have a concept called stocks, like containers, and we have flows like pumps, which define the transition thing. And then if we look into the different components, we can see there is a package called stocks and there is a package called flows. There are several other packages, but let's get started with these two first. Okay, so now I will open step 2, which is in the other domains, step 2 under the exercises package. So I will double click on step 2, and here I will check the name so that I can verify I have the right uh, f- uh, uh, model open. Now let's go to the stocks uh, package first. So here we have the information level and we have the material stock. If I hover over a component, I can see that there is a small description and it says unrestricted reservoir to store information. This means that the value might go below 0 as well. And then if we hover over the material stock, then it says reservoir that cannot be drained below 0. So it has a constraint that you cannot drain it below 0, and probably that's what we should use. So let me just drag a material stock for now, and then I would need a flow, right? And I have different types of flow: unidirectional, bidirectional, or interaction. Those are more advanced concepts, but let's start with the unidirectional flow. And here you can see a flow with check valve, flow with check valve outflow, and different other types of flows. The thing that is similar to the model that we did, the component that is similar, is the proportional transition uh, rate, as you can see here. Let me just drag the block here. So let's just use these two components from the library and start creating our SIR model, so that it will, and during this process we will look at the different parameters in the library, how to deal with units, and try to use the library better, right? So if I open my Mathematica notebook, so here let's uh, uh, recreate this model where we have unaware, aware, trials, customers, and all these things using those two components, right? Okay, so let me start by renaming things. So I have aware, and then I have uh, ads, right? And then I will just copy this and duplicate. Yes, here. I want to extend my diagram screen, so I put the select the red uh, button here, and then I will just drag my screen and double click to zoom and fit window. I will select all and move it towards the left hand side. So I have aware, I have the ads. Now I have, sorry, this is unaware. Unaware ads. I will name it to aware. Uh,
Can you zoom in a little bit to better see the icons?
yes, yes. Is this fine? Yes.
Yeah, that's much better.
Okay. I've spoken so much that I forgot what was the names that I had. Okay, anyways, once you have a trial, once you're aware, you would need examples. Uh, and then you become trial. And then we have experience. And finally, I will need another stock. So I will duplicate this by pressing Ctrl plus D. And then I will press F2 to rename it. And then I will say customer. Right. And then let me zoom back a bit. Right. Okay, Leo, do you want to do you have anything to say so far? So what I have done so far is I have I took two components. First we saw the examples. From there I tried to match uh, the elements which corresponds to the population group and transition. We looked into the stocks and flows sub package, and we started creating our model like this. Uh, right. Do you have any
Mm.
comments, Leo?
Do these models have enough documentation, for example, to see what the other transitions do?
Let's let's try to see that. So let's say I want to see the documentation for check vol inflow. I will select that component by left clicking on it, and then I can press F1, or I can right click and go to view class documentation, and then you can see it has this nice description is of what it does and how it has been implemented, and then it gives a description of what are the um, connectors that it has. And then if one wants to go into like what does this unidirectional mean, perhaps, and I can look into the documentation for that as well. So I right click, view class documentation, and then it tells me what this package contains and what are the different components it has, with a single line description of what each of the component does. But whenever you're trying to use a library, Leo, as we discussed in the start simple thing, you have to start with one or two components, try to model it, and then try to understand. No matter how many documentation you read, the until and unless you start simulating the model, trying to play around with the parameters, you will not get a grasp of the components.
Right, and probably in this case, the top level, so the main package has like more information.
Yes, you have.
Oh, there
If
is
I
a user guide there.
Yes, so if I press user guide and press F1, and then you have a tutorial. So, and then you have three different tutorials, like uh, explaining how this thing works, giving a simple introduction on the system dynamics concept, and then the elementary building blocks, like what does stock means. It says very comprehensive documentation of everything is there here. And then uh, this business simulation library, since it deals with systems, it's not as simple as the electrical system where we deal with ampere, voltage, farad, but you have a lot of different units here. So you can read about the different units available in this library. So there is some enough description, and also if you visit the library page on the link that I shared uh, in the session at the beginning of the session, you can see there is a video. There is a video where 20-minute video where we have explained about the library. Also, there are two or three different blocks. I think two blocks. There are two comprehensive blocks where we have where I have interviewed the library developer, and he has shown me the usages, what advantages it has. So if anyone wants to dig deeper into this library, they can read those blocks as well. Okay, Leo, and one thing you might notice, Leo, the unaware. If I zoom in further, to zoom in, I'm pressing Control, and then I'm using my scroll to zoom in. If people are curious, so if I zoom in, Leo, you can see the value of 0 is displayed. What does that value mean? That value is the initial value, the value of the parameter that is set. So so that is listed here. Okay, so I think people would have at least reached this step so far. Uh, so we have all the components here. Let's go ahead and connect them. I can connect by using the connection line tool, and then let me connect those components here. Yes. Okay, so now we have the elements in place. We have connected them together. Let's go and look at each block and try to see what needs to be set. So when I click the unaware uh, block, let me just try to select all of them, right? So that I can do. Um so now I have uh, pressed Shift and I selected all of my stocks. Uh, Now the output type. So depending, so you here you can specify the different like what is the type of stock. It can be a dimensionless stock, or it can be a quantity, it can be a population, it can be different things. So let's say I want to use a population here, so you can select what type of stocks you have. Um, so here I've selected my type as population. The initial value I will not set because I have all the components selected. I don't want a common value for all the components. So this I will keep it at 0 for now. And then other things also I don't need to change. And I think for now we don't need to play around with other things. So the only thing that we have changed is the output type, and we have set it to population each. Um, right. So now let me go ahead and select unaware, and I will select an initial value of 100 each. And then you can select between 1000, million, other things, but let's go ahead and select 100. And here, Leo, you can see 100. There is an ampersand sign here because sometimes the unit is um, not clear because things might have different units. And to avoid that confusion, we have this ampersand sign here, because you don't want the 100 people to be listed inside, right? It takes a lot of space. And then I will select aware, shift trial customer, and I will set the initial value of 1 each, just that we did in our previous model. So I have it at 100 and 1 for the other blocks. Now for the ads, okay, let me select ads, examples, and experience. So I pressed shift and I select all the components. Now the output type, uh, this we want a rate of flow, right? So per second. So here let me go ahead and select per second, or is there a people per second or not? No, right. So I can either select 1 per second or each per second, but let me go and select 1 per second for now. And then it has a uh, so this blocks, either you can feed in external input or you can define the value of the parameter. So for now, it has this parameter called has constant rate. I will set it to true so that I can set um, a constant fractional rate for all the components. So I set it to true. And now for ads, if I click on only the ads, I want to specify a value of it was 1 per day, I guess, or zero point 0.8 per day. Let me go back to my model. Ads, it was zero point 0.8 per day, right? So here I have 0.8. And when I press 0.8, you can see I can select from different units. 1 per second, one base point per calendar year, one base point per month. So this is in fractions. In some cases, I want things to be in fractions. Or I can have this rate per year, per month, or per week, right? But Leo, we want things to be in per day, and those are not listed here. And that is not listed here. How can we set that? How can we set it to zero point 0.8 per day? Is it possible, or I cannot do it?
Uh, let's try changing the unit, the display unit, to see if we can fix it to one per day.
And how do you change a display unit, Leo?
You are just there.
Oh, I'm just there. So the thing
Yes.
is, let's say this is set in 1 per second, but I want to have it in 1 per day. So I can click here, right? So I can click over the 1 per second here. It's sad that I cannot zoom in because I think some people who are using a small screen they might find it difficult. But yeah, let me.
Yeah. There
I'm
is the button only shows when you are on top of the display units.
yes, okay, and yeah. So when you hover over the display unit and click the button, you get into this view where you can see the unit is in per second, and whenever we don't need to change the unit to 1 per day. We usually work with the display unit, Leo, isn't it? Why is that? Like, why don't we change the unit, and why do we use display unit, Leo?
I mean, in a sense, it's nice to have to keep the base units to work everywhere with the base units and just changing the way that we see it.
Because
It in some cases, I guess that it could be useful changing completely the units, but
yeah.
probably sticking to the base, it's
Yes,
better.
because maybe you have equations where which takes into account the SI unit, and suddenly when you change the unit, you have some conversions that you need to take care of. And I find it always difficult when I deal with RPM and radians per second. I that's very
Right.
confusing to me. But usually but most of the time we work with the display unit. And even if the display unit of 1 per day is not listed here, if I go and type 1 divided by d for day, system modeler knows about it, and then uh, it automatically accepts it, Leo. Like, what happens under the hood, Leo? When I type 1 per day, what actually happens here?
So we are trying to determine what's the unit that you're writing and check if it's a valid one.
Yes.
So
So
if
of
it's
course
valid,
we have a we have a question here. We can There is a unit called 1 per week, but in this specific case, let's say we are interested in 1 per day. And then if it is not listed, we just try to write the unit like 1 per day and try to see if system modeler knows about it. And if system modeler knows the value of d, it will automatically try to transform it, right? Even if it is not listed. And now if I click OK, then you can see that my rate has changed to 1 per day. And now I can select 1, uh, and then this is equivalent to what we did. Similarly, for examples, I will also go here and change the display unit to 1 per day and click OK. And this one was zero point 0.5 per day, I guess. Let me just go back. This was zero point 0.5 and this was zero point 0.1. So here it was 0.5, and for my experience here, I will go and change it to 1 per day, click OK, and then 0.1. Uh, okay, so now I have, and I will give a minute or two for people so that people can actually change it and try to recreate this. So what we did so far, Leo, we selected the component, we changed the output type to rate. Here, the thing is, when you change the output type, the units are automatically inferred based on the output type. So it's useful in some cases. Uh, and then we set the display unit for fractional rate to 1 per day, and then we changed it for the other components as well. And also we changed the hash constant rate to true, right? Okay, so right. So the next step would be to change the experiment setup, and here I can set today. It's already set to 30 days, so I don't need to do anything, and I will press OK, and let's simulate this model. So Leo, do you have anything to add to this so far?
No, I just wanted you to show again
Hmm.
what how to change the settings in system in Model Center and send them to the model. Because someone
Okay,
was asking us to show it again.
right. So the thing is, you go to parameter, you change the value, like let's say to 1 or 0.8, because I was going to compare it, so I will not change it now. And then you change the parameter, you go to file on the top here, save experiment settings, and then all the changes are listed here. And if you want to accept the changes, click OK, and uh, it will update the model, right? Okay, so now let's get ahead. Let me clear this. um, yes, so it would be nice, Leo, to have a plot beneath this plot, right, so that we can compare and try to see if if it matches, or if we are way out. uh, so to create a subplot beneath this plot here, we can create this the plot with the plus icon here. And if I hover over it, it says new subplot. And if I click here, you see a new subplot is created, right? And here, let me go to plot, and then I will plot my unaware. And then if I click on unaware, you can see we have the value of y. So usually in a component, when you see the value of the alphabet y, it means output. And when you see the word u, it it means input. So usually u is used for input and y is used for output. So let's click on y, and then for aware, let me click on y here. Also, um, there is a trick, Leo, isn't it? Like if I only want to select y for all my components, I can use the filter thing also, right? So I can just type in y here. So when I type in y, I see all the things with y in it, and then it helps me to quickly plot things, right? So I can type in what I want, in this case y. It filters out those information, and then let me plot the customer y, and then the was it trial y. Yes, so now you could see with the new model that we created, we get the similar response in our as our original model. In the original model, what I did, you could see that it has steps, because the thing that I did was I passed it through a integer conversion function. So it converted my real values to integers. That's why you could see those steps. Whereas using the library, we treat the values as decimal, so a real value, as real numbers. So you don't see those steps. Yes, Leo. Okay, Leo, do you want to add something to what we have seen so far?
No, it looks pretty much the same, right?
Yes, it looks the same. Um, right. Are there any questions up to this point, Leo, that we should cover?
Uh, well, we probably were running out of time, so let's give them a little bit time
Yes.
to
Um,
ask some questions.
yes. One last thing, Leo, I actually wanted to cover today. Um, so since we are out of time, people can actually uh, uh, try out the impact of decision. Um, um,
Right, that will be interesting if you can make it quickly, like changing the ads.
yes. Yes. I think I should do it. Yes. Okay. Uh, right. So far we have seen that we have a constant rate, but uh, but um, but we know that when we try to model a scenario, we want some change. Like we want some a linear growth. Sometimes we want the rate to change linearly, or we want the rate to have a pulse kind of signal. So or we will see later today, we want to be able to tune it. Uh, okay, I will stop at that. Let's first start with if you want to have a external rate, how we can use an external rate to define the rate value for this. So now, when in the first case we had the constant rate to true, let me set it to false. And when we set has constant rate goes to false, one could see that we have a blue arrow on top of it. And if you look at my examples, we don't have a blue arrow over here. So what happened when I selected has constant rate goes to false is that a input um, sign has popped up, and here I can connect to other source blocks, right? Uh, and in the business simulation library, you have this information sources. And if I click on the information sources block, you have a constant input, you have a pulse input, you have a ramp input. So you can try out between different types of sources, and your rate value will follow that shape, right? For example, let's start with uh, the basic first. So let's say I have the constant input block, so that we replicate what we just did, just to see that when we had a constant rate of 1 per day, and if we add an external input, we get the same behavior. To do that, I dragged in my constant input. I will change the output type to, if I select in the menu, there should be 1 per second somewhere. uh, yes. So in the output type, I select 1 per second, because this is the rate that I'm trying to specify. And then I will change my display unit to days, as I did before. And here now I can set it to 1 per day, right? So which it was 1 per day. And now I get the same block. I can just press C and then connect it to my real input. So here now I have a constant source. I'm plugging it to my add input, and let me just simulate. This is just to see that I understood how this real block works, or this real input works, right? Okay, so you see that I have the same trend here. So it's the same. Uh, so what this constant block did is the same as if I had this constant rate goes to true, and I had set a constant rate here. Instead of doing it, I have a constant block like this. But what if, let's say, you are invest like you want to start a ad campaign, like you want to invest in a new social media platform, you want to put in more money, and you are expecting that when you have this campaign, you will attract a lot of people, right? So to model this campaign, I will model it as a pulse input, because you want to have the campaign for a span of time. You don't want to continue it uh, uh, all the time. So here I have a pulse input.
Ankit, a small request. Can you use, for example, the linear timetable? That way, it's possible to show how to use it, how to pass like a lookup table.
Hmm. Uh, yeah, sure, sure. I can do that. I had actually planned that for a future session, but I can do that as well. It's fine. Okay. So the linear timetable is basically you can specify um, a time series, right, Leo? To um, uh, you can specify time series as a rate, and then once I drag in my linear timetable, I will set the output type. I will set the output type to 1 per second, and then I have my start time goes to 0, and then I can select the values here. I can go to edit, and let's say at 0 we have 0, and then at um, maybe at 30 days uh, we have maybe 2 or something like this. Right, and the time scale is in days, so I will select the time scale in days, click OK, and I'll put it to 1. So that means that the 30 value that I have mentioned here, it's actually in days and not in seconds, which is the usual, um, which is a default case. uh, right, and right, so I have the output in per second. uh, right, yes, uh, right. I think when I use this, I have to use another component here to convert. So what this will do when I use this linear timetable is it will provide me an output in per second, right? And that output in per second, I have to convert it to per day. Um, uh, so I need to have a rate conversion actually to convert those things. So the thing is, in my table, I provided in the first axis, in the first column, I provided the time in days, and in the second column, I provided the time in per day thing. So I will select this rate conversion. The time base A is in, I think is in days, and I want it to, the input is in days, and I want the output to be in seconds, which is the base unit for ads. And let me just simulate this. So Leo, this is what happens when you try to to change my workflow in the middle. I have to think a lot. Anyways, okay. So we get this type of curve now. So initially you could see that when the rate was 0, we had a flat kind of curve. There was no transition to aware, but as things progressed, we had the rate, and people became more aware of the product. Uh, right, and let me just try to plot it. So line timetable y, and then uh, right, yes, and this is in per day. Yeah, here you can see the curve how it goes, right? It's just that when I deal with per day and with the units, I have to test a bit. As I said, this might be confusing for a lot of people, like why did I need to use a rate conversion thing? And the reason being the output value is in per second, and I need a way to convert that value to something that is compatible, and that's why I had to use this, right?
Right. It is important to be very careful when dealing with units that are not seconds.
Yes, and that's why I had planned it for, we will be using it in a session on, I think, Monday or Tuesday. I think on Tuesday we'll be using it again. But Leo, before we conclude, I wanted to show something cool as well. So uh, So let's try to gamify our simple model that we have. Like, what if you don't want to specify a input now, and you just want your sliders in simulation center, and you want to use the sliders as controllers, right? How can you do that? So to do that, we will create a input, and to create an input, you I will go select connection line, click on the input, and then right click, and then say create connector. So here what I did was I created an input for my model, but I didn't specify any value to it, right? It's a simple input that I created. And to do that, I used the connection line tool, dragged in a connection, right clicked, and said create connector, right? Okay, escape. Right. Now what I want to do is I want to add a slider to this input and then test scenarios live in simulation center, right? And to do that, I will first, let me just simulate. So when I simulate without attaching any value to my input, the value is taken to be 0. So I am expecting no, uh, yeah. So I'm expecting the 0 value, right? So there is no transition across the different stages, because since I didn't assign any value to my input, it's taken to be 0. Now let me add a control panel and give it a name, model, uh, model input, and then I'll click, I will create a control object, and here you can see the name of my input, which is U1, and I will give it a name, input control, and then I will use a slider and specify the value, let's say 0 per second, uh, something like 2, let's say 1, or maybe 2 per second, and click OK. Right. And here, if you see, if I start moving it, let me delete this unused plot, remove subplot. Right. And as you see, if I change my control, maybe this value is too big.
Yeah, I think it's per second, and the per second should be very, very, very small.
It should be per day, right? Something like this.
Yes.
Yes. Yes. And if you see, if I change this, I'm able to see different changes, right?
Can you remove the one on top to not be confused?
Oh, right. Okay. Let me just remove this. Right. Yeah. And if I move this, I can see that this is changing. My display unit has changed. So I will do right click, display unit, and it goes to days. So you can see I can test different scenarios. But the thing, Leo, what I wanted to show was, uh, so what happened here is when I changed the input, it behaved as a normal parameter, right? So when I'm changing this value, it's taking a constant value and it is changing things. But that's not interesting. I want to change things live. I just want to use this controller as a signal and then try to change it as the simulation runs. And to do that, let me run this simulation in real time, or kind of real time. So I go to settings, I select synchronize with real time, and of course I don't want the time scale in seconds, because here I'm dealing with days and we have to stay here for 30 days to see the simulation. So I will increase the time scale, let's say to 1 hour. So it's like how many seconds? 3600.
3,600. Yes.
Yes. So now I am increasing my time scale, and I selected the synchronize with real time, and I will click the play button here. So now you can see, uh, with this fast real time, things are changing. And as I try to play around with my sliders, if I go to extremes, you can see the values are changing. And then if I go to 0, it is stagnant. So you can imagine, like, you are trying to achieve a target, and then you don't know what input you want, and then you can just play around with the input control and see how the different stocks, or how the different transitions are happening. right? So if you have multiple parameters, like in this case, we just had an input for the ads rate. We can also imagine having inputs for different other blocks, and then you can uh, you can run your simulations in real time, and then you can use the sliders to tune it or test different scenarios. Like things are going business as usual, you try to do a change by increasing the ads, and then you see how the system would respond. Okay, Leo, I have spoken so much. Now, do you have anything to add?
No, no, that's it. I think it's
Yes,
quite nice.
yes. There was a question on adding delays. Um, so I just wanted to point that out. Uh, so in the stocks, we have this material order of nth order delay component, which has this delay in it. And if one wants to learn more about it, they can open the SIR model, and you can see in the infected section here we have added a delay instead. So it's not a normal stock, but it is stock with delay. And if one wants to know more, they can run this model or try out this model by using one or two different components, and then try to see how the component behaves. Right. Yes. Are there any questions, Leo, before we wrap up? Oh, there is a question regarding vectors. Uh, yeah, Francisco. We can have vectors as well. Um, so here, for instance, if you look into the converters section, we have a vectors group as well. So if you have a product, you can uh, connect multiple signals to it, and then we can have vectors. So it is possible. I'm not going to cover today. It's already we are way past our dedicated time. But yes, we can have vectors as well. Um, do you want to add anything to it?
No, I think it's fine. Let's wrap up.
Yes. Okay. Um, thank you everyone for attending today's session. Have a nice weekend, and see you on Monday. Have a nice day. Bye bye.